There is a stretch of water at the bottom of the world that has sunk over 800 ships, and it's only 600 miles across. That number doesn't feel real until you start doing the math. 800 ships, tens of thousands of voyages, 10,000 men believed dead. A passage that has been sailed for centuries, mapped down to the meter, studied by meteorologists, feared by every sailor who has ever had to cross it, and it still swallows vessels whole. Between the southern tip of South America and the frozen coastline of Antarctica, there is no shelter, no barrier, no land to break the wind. The ocean here circles the entire globe without interruption, and every drop of energy it builds comes crashing through this single 600-mile gap. This is the Drake Passage. It is not the world's most dangerous body of water by reputation. It earned that title, one shipwreck at a time. A monument stands on the Chilean cliffs above it, carved in the shape of a wandering albatross, dedicated to the men the passage never returned. The sea does not read monuments, and it is not a route. It is a threshold. The world has calm oceans, and it has cruel ones. Then it has this one, a place where the entire Southern Ocean is forced through a gap it was never designed to fit through. A place where wind circles the planet uninterrupted and arrives here at full weight. A place where waves have risen higher than a 5-story building and shattered the windows of ships built to withstand almost anything. The passage keeps its secrets carefully. Some it releases decades later in the form of wrecks discovered on the seafloor. Others it keeps forever. And still, every year, vessels choose to enter it, because for all its violence, the Drake Passage is the fastest way from one side of the world to the other. There is no alternative that does not cost days, fuel, and risk of its own. To understand why sailors continue to gamble with it, we have to begin where the passage begins. Not on a map, but in the geology beneath it. The opening of the gate. The Drake Passage was not always here. For much of Earth's ancient history, Antarctica and South America were joined. A single continuous stretch of land curved down from the equator to the pole. There was no gap. There was no gauntlet. The oceans north and south of that land bridge circulated independently, and the planet's climate was very different because of it. Then, somewhere between 49 and 17 million years ago, the tectonic plates began to pull apart. The exact date is still debated by geologists. What is not debated is the consequence. A narrow channel opened between the two continents. Salt water rushed in. The land bridge drowned, and the world changed. Because the moment the passage opened, something began to circulate that had never circulated before. Water could now travel completely around Antarctica without ever meeting a coastline. Not once. Not anywhere on Earth. This single, unbroken corridor gave rise to the Antarctic Circumpolar Current. It is the strongest ocean current on the planet. It carries more water than every river on Earth combined, several times over. It moves at a scale that is difficult to visualize. Roughly 150 million cubic meters of water pass through it every second, and it flows clockwise around the pole, gathering momentum with nothing to stop it, nothing to slow it, nothing to break it apart. Then, on its journey around the continent, it reaches the narrowest point in its entire circuit, the Drake Passage. All of that momentum, all of that mass, squeezed through a 600-mile corridor. The water has no choice but to accelerate. The physics is merciless, and the physics is the beginning of the danger. The coordinates of the trespass. The passage lies between Cape Horn, on the southern tip of Chile, and the South Shetland Islands, off the coast of the Antarctic Peninsula. Ships that cross it move between the Atlantic and the Pacific, threading a line that has been used by explorers, whalers, freighters, and now cruise ships and research vessels. Beneath the surface, the seafloor is not a smooth basin. It is a landscape of ridges, troughs, and abrupt gradients. Depths range from just over 11,000 feet to more than 15,700 feet in places. The topography beneath the water contributes to the turbulence above it. When a strong current meets a rising ridge, the water is forced upward and the surface responds with chaos. To the north, the water is subpolar. To the south, it is polar. Where they meet, At what oceanographers call the Antarctic convergence, cold and warm masses collide. Temperature gradients like this drive eddies, circular currents, whirlpools of scale that are visible from orbit, and above all of it, the wind. Because there is no continuous land between the passage and the equator of the southern hemisphere, wind can travel thousands of miles across open ocean before it arrives here. It gathers weight, gathers speed, gathers moisture. It carries the memory of every storm system it has crossed. Gusts in the Drake Passage regularly exceed 70 miles per hour. In severe systems, they exceed far more. This is what waits on the other side of Cape Horn. Not a crossing, a collision of forces. The first to see it. The passage was first sighted, though not intentionally entered. In 1525, a Spanish navigator named Francisco de Hoses was blown south of the Strait of Magellan by a storm. He saw open water where cartographers of the era had drawn land. On many Spanish-language maps, the passage still carries his name, Mar de Hoses. The English name comes from another sailor entirely, Sir Francis Drake. In 1578, one of his ships was similarly forced south by weather during his circumnavigation of the globe. He never actually sailed through the passage that would come to bear his name, but his vessel proved, again, that the land bridge assumed by European cartographers did not exist. Below South America was open sea. The first documented intentional rounding of Cape Horn did not happen until 1616, when the Dutch navigator Willem Schouten deliberately steered around the Cape and entered the passage on purpose. When news of his voyage spread across Europe, the implications were immediate. There was a way through, a way that did not require threading the narrow, treacherous, current-choked Strait of Magellan. A way that was on the map, faster. On the map, in the reports, it would become the graveyard of the age of sail. The pattern of loss. The wrecks accumulate quietly, ship after ship, century after century. No single disaster defines the Drake Passage. Its danger is not a moment, it is a pattern. In 1741, a British warship of the Royal Navy became separated from its squadron while rounding Cape Horn in appalling weather. The vessel was driven onto the rocks off the Chilean coast, and what followed was one of the most infamous shipwreck sagas in maritime history. Mutiny, starvation, small groups of survivors setting out in improvised boats in different directions. Of roughly 120 men who had left England aboard, only around 10 made it home. In 1819, a Spanish ship of the line was dispatched south to reinforce colonial forces in Peru. It was last seen entering the Drake Passage. It carried more than 600 men. It never emerged. If any of its crew had made it to Antarctic land, they would have been the first humans in history to set foot on the continent. Instead, the passage closed over them without record. These are not isolated cases. They are examples of a category: whalers, freighters, naval vessels, fishing boats, research ships. The Drake Passage does not discriminate by purpose or by era, and into the 20th century, it did not soften. The voyage that should not have survived. In December 1914, an expedition set sail from South Georgia, aiming to become the first to cross Antarctica on foot. 28 men, one wooden ship, a polar winter closing in. The expedition never reached the continent. The ship became locked in pack ice in the Weddell Sea, and over the course of months, was slowly crushed. It sank in November 1915. The crew survived on the ice, then in 3 small lifeboats, drifting toward a barren island at the edge of the Southern Ocean. From there, 6 men were selected for what remains one of the most improbable open boat voyages ever attempted. Their target was another island, some 800 miles away, across the Drake Passage and its surrounding waters. Their vessel was a converted lifeboat, barely large enough for the crew to lie down. For 16 days, they were battered by the passage. Waves the size of buildings, wind that ripped spray from the tops of the swells, freezing temperatures, constant water in the boat. They arrived. The rescue that followed brought back every man from the original expedition. Not one was lost. The ship itself was rediscovered on the seafloor in 2022, over a century later, preserved with extraordinary clarity by the cold, dark, oxygen-poor waters at depth it had waded. The passage sometimes returns what it takes, almost always long after anyone remains to receive it. The modern casualty. It is tempting to imagine that the Drake Passage belongs to the age of sail. That radar, satellite forecasting, reinforced hulls, and stabilization systems have neutralized it. They have not. In late 2022, a modern expedition cruise ship, purpose-built for polar waters, was crossing the passage on approach to Antarctica. It was struck by a rogue wave, 16 meters, roughly 52 feet. The wave shattered the reinforced windows of multiple cabins, sent seawater cascading through the ship's interior, injured passengers, and killed a woman in her 60s. The ship was not old, it was not undersized, it was not off course. The passage simply reached up and struck it. This is the reality that governs every crossing today. Advanced weather routing, modern hulls, decades of accumulated navigational knowledge, none of it removes the essential arithmetic of the place. A funnel of water, a limitless supply of wind, and a wave that no forecast can fully predict. The Drake Shake. Sailors have a name for what a rough crossing feels like. The Drake Shake. It refers to the specific combined experience of the passage at full strength. The pounding of oversized swells against the hull, the lateral roll induced by wind pushing on the ship's superstructure, the vertical drop as the vessel crests a wave and falls into the trough behind it, the unpredictable shudder of eddies passing beneath the keel, the vibration of engines fighting a current that is trying to redirect the ship. It is not seasickness in the ordinary sense. It is a full-body reminder that the vessel is not in charge. The alternative, on rare occasions, is what crews call the Drake Lake, a crossing in which, for reasons of timing and pressure systems, the water goes quiet. The passage becomes almost mirror flat. Wildlife surfaces, albatrosses glide. Sailors describe the Drake Lake with a specific unease, because they know what the passage is capable of, and a calm crossing feels, to those who have made many, like something is being held back. The passage is stronger than us. That is the rule every captain works under. The ice that drifts north. There is one more danger. Antarctica loses ice. It always has. But in recent decades, the ice shelves that ring the continent have been calving larger and more frequent icebergs into the Southern Ocean. Many of these drift east, carried by the same current that dominates the passage. Some fragment quickly, some do not. In May 2021, a single iceberg broke free from an ice shelf on the Antarctic coast. When it was first measured, it covered an area of roughly 4,320 square kilometers, larger than several major islands, larger than some small nations. Within weeks, it fractured. The largest surviving fragment still measured more than 100 kilometers in length and more than 20 kilometers wide, roughly twice the area of a major world capital. It drifted northward for months, carried on ocean currents, before eventually breaking apart in warmer waters closer to the passage. These are not rare visitors. They are recurring residents. Icebergs of significant size drift into the shipping corridor with regularity. Radar detects the large ones. Smaller fragments, called growlers and bergy bits, are harder to see and can be as dangerous. A block of ice the size of a truck, riding low in the water, can open a hull at cruising speed. The passage's list of hazards, then, is not one thing. It is a stack. Current, wind, waves, eddies, ice, cold, distance, from rescue. Each is capable of ending a voyage on its own. Combined, they define a stretch of ocean that has no true equivalent anywhere on Earth. The choice to cross. Given all of this, the question becomes not why the passage is dangerous, but why anyone continues to cross it. The answer is that there is no better option. The Strait of Magellan is narrow, current-swept, and requires pilots familiar with its channels. The Beagle Channel is narrower still. Both add days to a voyage. For ships too large to enter constrained waters, modern cargo vessels, research ships, cruise liners, the open passage is the only practical route. For scientific expeditions, it is essential. Antarctica remains the most poorly mapped continent on the planet, and the passage is the fastest sea route to reach it. The Antarctic Convergence, where cold polar water meets warmer subpolar water, sits within it. That boundary is one of the most biologically productive zones on Earth. Krill swarm there, whales feed there, seabirds gather in numbers that are difficult to count. For tourism, it has become the standard route. Ships depart from Ushuaia, the southernmost city in the world, and cross to the Antarctic Peninsula. Passengers pay for the crossing knowing what it is. They pay because the alternative is not seeing Antarctica at all. And so, the corridor stays busy, not crowded, but used. Captains who cross it repeatedly speak of it with a specific tone. Not fear, not bravado, something closer to negotiation. A captain of one polar expedition ship put it plainly. The crossing is not made on schedule. It is made when the passage permits it. Courses are altered. Angles to the swell are recalculated by the hour. The final destination sometimes waits while the ship holds position, or turns broadside to a system, or accepts a longer route to avoid a worse one. The ocean is stronger than us. That phrase, in various forms, repeats in almost every captain's account. What the passage refuses to answer. For all that is known about the Drake Passage, much of it remains unresolved. Oceanographers still argue about how much of its violence is driven by the current itself versus the wind above it versus the seafloor beneath it. The interaction of the three creates conditions that computer models struggle to reproduce faithfully. Rogue waves, the sudden, disproportionate walls of water that have destroyed ships and injured passengers on modern liners remain incompletely understood in this region. Some researchers suggest the collision of the current with submerged ridges focuses wave energy in ways that produce these anomalies. Others point to constructive interference of independent swell trains. The debate is active. The full toll of the passage is unknown too. The figure of 10,000 sailors is a widely cited estimate, drawn from centuries of maritime records and the assumption that many losses were never formally reported. The true number is almost certainly higher. Ships that vanished in the age of sail often left no trace, no signal, no wreckage recovered, no confirmation. The seafloor of the passage is still being mapped. New wrecks are still being discovered. Recent expeditions have located vessels lost more than a century ago, preserved in cold darkness at depths where light does not reach and decay is nearly suspended. Each discovery closes one loop. Many more remain open, and the ice continues to drift. The behavior of Antarctic ice shelves in the coming decades will determine whether the passage becomes more hazardous or less. Larger, more frequent icebergs would extend the danger zone northward. A warmer southern ocean would alter the current's behavior in ways that are, again, debated. The passage is not a solved problem. It is an ongoing one, the threshold that holds. Every ocean on Earth has coastlines. Every stretch of water has, somewhere, a shore where the wind must eventually stop. Except one. The Antarctic Circumpolar Current circles the planet without ever meeting land. It is the only ocean current in the world that does. And the Drake Passage is the point where all of that unbroken motion is compressed into its narrowest expression. The result is a place that behaves less like a strait and more like a wound in the map, a gap where the ordinary rules of coastal water do not apply, where the sea does not decelerate, where the wind does not divide. Ships have crossed it for 5 centuries now. Some of them, like the small open boat that carried 6 men to rescue after their ship was crushed in the ice, arrived on the other side against all reasonable expectation. Others, like the naval vessels of the 18th and 19th centuries, disappeared into it without leaving a message that anyone could recover. The monument at Cape Horn still stands, the albatross with its wings spread wide, carved into the wind. 10,000 names it does not carry, because the names were not always recorded. 800 ships beneath the water it faces. And every hour, somewhere in that 600-mile corridor, Another vessel begins its crossing. The captain watches the pressure charts, adjusts course, chooses an angle, accepts that the arrival time is a suggestion, not a promise. The passage listens, and the passage decides. Somewhere in its depths, ships that entered centuries ago still rest in the cold and the dark, undisturbed by anything except the current that carried them there. Somewhere on its surface, a wave is rising that no forecast has yet detected. Somewhere north of the ice shelf, another iceberg the size of a city is beginning to drift. The world's deadliest passage of water is not deadly because of any one of these things. It is deadly because it is all of them, at once, without pause, without warning, in the only place on the planet where every ocean on Earth is forced through a single gate, and the gate has never closed.